Då kan vi gå vidare till vårt sista anförande före bensträckaren, och det är Emil Fresk som står där, som ska tala om robotik och automation. Välkommen Emil.
Thank you. Let's see. Yeah, this seems to be working. So, hi all. My name is Emil Fresk. I'm a researcher with the robotics team and in the control engineering group of here at LTU. And I'm going to give you some insight into how robotics and automation connects to these ideas of AI, and how we are trying to bridge not only the theory of robotics, but to actually take robotics from the lab and apply it in real life. Because if we do not apply robotics in real life, from our team's view, then what's the reason to do robotics? We want to see it have an impact in real life. And to start with, our group, we do a whole set of different robotics-related research. Our two main areas are currently in aerial robotics and inspection robotics. However, we have been touching on multiple different areas as well, and most of them are listed here. And I would like to highlight that our current collaborations are with, firstly we are with NASA. I'm not sure if you are aware of the DARPA challenges. I guess everyone has heard of the DARPA challenges. One of the big ones right now is the one called the Subterranean Challenge, which is more or less to use micro-aerial vehicles, or drones as they're more commonly referred to explore tunneling networks and find specific items within these tunneling networks without any prior knowledge of these prior networks. So like taking a drone and sending it down, let's say, a mine, and it should just find the thing you want it to find. This type of problems. On top of this, we have collaborations with both LKAB and Boliden, which are actually our current main partners in one of our largest projects, which I will come to, where they are supporting us with mines, and we are trying to apply inspection robotics in mines. So rather than sending your people into the dangerous areas, send robots. You don't need to have people be in the dangerous areas when you can have robots be there. Together with this, I heard just yesterday with Ericsson that we have been granted the 5G testbed, if I understand correctly. So if you have robotics, the key in all of this is communication. I mean, if you are talking about AI, everything comes back to getting data. So if you don't have a data uplink or downlink, what will you do? Either you have to pre-train your system, but then you will not have it adaptive online. So having a communication backbone is extremely important for robotics in junction with AI. And with Honda, we have a project for robots in your home. So how is the future assistant more or less going to be like? Where Honda is our main collaborator, or we are collaborating with Honda. So let me then start with one of our main projects we had. And this one was called ARIAL, which was for collaborative aerial workers. And the whole idea here is, and I will just check, is the muted? Because else it would go crazy. Yes. Just so we have it going. The whole idea of ARIAL was that given infrastructure, in this case, this is from our field trials in Burio, Skellefteå, these wind turbine power plants or other type of infrastructure, inspecting this is currently done with rope teams. So you have people hanging with ropes from these tall structures. And it actually turns out, unfortunately, that people die due to failures of safety equipment or just simply being in a hazardous environment. But what we want is this. Why would you send people when you can send drones? If this one can do all of the pre-inspection, so you only need to send people when you absolutely have to, I would always send the drone let's say. However, of course, making an application like this happen, it's not something that happens overnight. This was 3 or almost 4 years of research to have a fully autonomous drone, so there's no pilot. It's simply a go button, where you have given the drone, or actually in this project, multiple drones, the mission to inspect this infrastructure. And then it comes down to, how should they just fly in order to not collide with each other, not collide with the infrastructure, not collide with the forest below it? All of this comes back to path planning algorithms, which in sense is AI. They need to understand that I cannot fly into a tree, I cannot fly into an infrastructure. And here, from the final part, when we have actually multiple ones. And what we are very proud with this is also to be able to say that this type of systems, they work when GPS fail. I don't know if you realize how reliant you are on GPS, but these type of systems work without GPS. Actually here, at this wind turbine, GPS does not work. It's a bit interesting. Simply because the wind turbine is such a tall tower, it actually disturbs GPS. But at the end of this project, ARIAL, we were actually awarded by IVA, one of the top 50 engineering works for this work. And now, just recently, that was 2017, now in 2018, we were awarded one of the top 100 innovations for this work. So we hope that this will actually be picked up a bit more by, let's say, the industry. But if I continue, what we're currently working in is the continuation. And before we were inspecting large structures outdoors. What can we do if we have to go indoors? Or even worse, underground? In mining, I guess everyone has heard of some accident happening in mining. Tunnels collapsing, the roofs are not stable after blasting. What we want to come to here is use drones. So, what we've been currently working on, just to give an idea here in SIMS, which is Sustainable Intelligent Mining Systems, is that we want these drones to, without knowing their tunnels, or knowing a tunnel network from the mine, this should be able to go, inspect, and report back that, are these tunnels safe for operation? Or it could also be simply that there has not been a collapse of a tunnel. And what we're going to see is in this work, to detect how to go into tunnels, you actually need machine learning. It turns out that many of our normal methods, they do not work for detecting tunnels. So here we actually have a convolutional neural network system that detects where's the center of a tunnel to simply continue exploring tunnels. So what we are doing in this type of system is we simply go in the tunnels, since we have no data here. So we need to start with data collection to just figure out, how do we move this? How would a camera see what is forward, what is left, what is right? This is then collected there, implemented on one of our drones in our lab. And what it in the end does is that only by then simply knowing that darkness or specific textures of walls, it knows that it should go either forward, left, or right to continue and just traversing these tunnel systems. And you can actually see it, how it's looking for walls all the time. And in our previous experiment, or our latest experiments down in actual mines, this is at about 800 meters below ground, 800 meters. We got about 500 meters, or until the battery ran out. These systems can autonomously now explore tunneling networks, where AI stands for the power to, let's say, not collide with a wall. But to continue with more of our work in inspection and maintenance, we have a large focus in our group on flying robotics. However, we also do, let's call them climbing or ground robotics. And what has been under heavy development during the last years has been what is now more commonly referred to as vortex actuation technology. And what it means is, it's a robot that can stick to surfaces without magnetic adhesion. So let's say, in this case, it is for inspecting airplane bodies. These are made out of composites, so you cannot have, for example, magnetic wheels to stick on surfaces. So what is done here instead is to simply use, let's say, a huge electric fan to suck to a surface. And then one can say, but this maybe doesn't sound so special. Well, the interesting thing is, depending on how you place this electric fan and how the inlet looks, you can go from just about 2 kilograms of suction force, which is what this motor can generate, up to about, I think, 7 or 8 kilos, 7.5 kilos, only by doing the correct control and of the distance between this motor and the surface. So we can more or less 4 times improve the adhesion force of this type of systems. So what this means is, you can have it on an airplane, in this case, or other surfaces, but you can also carry the sensors. This is the important part. Having a robot on an infrastructure doesn't mean anything unless you get the data that you want for later analysis, which usually is finding faults, finding cracks, and a similar type of faults. And what is then the whole idea? Because now we've been showing examples. Well, the core idea of this lab is that we want to be able to take research that is done, fundamental research, and it shall be applied eventually in real life. But you must take steps to go from core research or fundamental research to experimental validation in real environments. And for this, we have the Field Robotics Lab. And the whole idea here is that first, inside the lab, we can test our algorithms inside a motion capturing system, which is the camera here on the image. I guess everyone has seen how they make 3D movies. They put on a funny suit. They have like balls on the suit, and if they move, the computer sees how you move. It's exactly the same idea here. It's exactly the same system even, only that we apply it on robotics. And the whole idea here is then you can exactly know where a robot is. If you know that exactly, you don't need sensors, so you can test your algorithms without even having a sensor. You can test even sensors that don't exist. You can make made-up sensors, let's say. And the system we have, it can capture about 150 to 20 meters. This is a really huge system. Oh, it says millimeters. Should be meters. And the whole idea is you can put on anything. You only need to put something that's about 2 millimeters of size on your robot, and then you can track it, or a few of these tiny, tiny markers. And we have larger markers if you want to have large systems. We are also developing our own positioning technology and communication technology. When it comes to ultra-wideband technologies, these are starting to become quite popular for indoor positioning. And for humanoid work, which is one of our also research, we are using what's called the proportional pneumatic network, which simply is a way to control a lot of pneumatic muscles. It's a way to replicate human muscles using air pressure. And with this, so I hope you have gotten an overview of our work, how this relates back to, let's say, data analysis, AI, and machine learning, and how we use this to perform these type of tasks. And just to show everyone, which is our team currently at the university, which is part of the inspection and maintenance robotics, or the robotics team as we call it. And with that, I think I'm on time.
Thank you. Är det några frågor till Emil? Per har en fråga. Ja, det kommer en mick här.
Should I take it in English, perhaps, since your talk was in English? The underground drones, what payload can you put on those drones that you have in your minds?
The ones that we're running right now, we never actually see payload. Usually what we ask is, what payload do you want? And we always design that the drone around.
I want a lot.
Yeah, for example, the one we showed in the videos, this one has about 500 grams of payload, because we only wanted a small drone with minimum payload to show algorithms. We have another one which has a requirement of 3 kilograms of payload, which is currently under development. So we simply say, which payload do you want? And then we design the drone around the payload.
What I was thinking was that, can you actually map out the drifts and the tunnels in 3D while you're flying?
Yes.
And can you put a sensor to map an IR sensor, for instance, on the drone? You can actually, in real time, draw up the geology of the drift.
Yes.
Excellent. Then, and I'm extremely satisfied. Thank you.
We have it all solved. Thank
Of
you.
course.
Any more questions for Emil? Oh, there's another question here.
We need more microphones.
Yes, we do.
Exercise.
Thank you. My question has to do with one of the fears people have with robots. There's a fear that maybe robots will take over all our jobs. For example, they may start teaching in classes and we wouldn't have need of professors. How realistic is this fear? Should we be worried?
Well, how we see it with the robotics we are doing is simply to replace people with robots when people are in danger. This is the core aim of everything we are doing. So, and this is also the only type of applications we are aiming at. However, there are probably a huge societal change going to happen. Let's say that cars can drive themselves. What will happen to the transportation sector? It's a huge question. It's a very difficult question that I don't have an answer to, but something is going to happen, to be honest there. But I have no idea what will happen.
It's a discussion for the lunch mingle, I think.
Yeah.
Thank you. Tack, Emil.
Thank you.